Heck no, I don't know how to do that. Yeah, so since I didn't find that everything, right now it's like enter value A 5.
Perfect.
Yeah, enter value B 6.
And can I change it?
C is 61. Yeah. Yeah, because I didn't like do the square root, so square root.
What about 23? Would it work?
Yeah.
Cool.
Whoa, why is it like lagging?
Oh, because this. So it actually pauses for 20 milliseconds.
Yeah, it does.
Yeah, before you lay on that. Actually, that's a nice touch. That gave you the action, show you how exactly it's laying.
It's like fast motion, like bricklaying. No one can like bricks.
So let's actually try to find out how you did it, and the y. So here y is get height minus break height, which means that y is this position right here, right? And then for n equals breaks in base. So n is starting from 23 and count down to 0. And starting from 23 and count down to 0. And then row length is so row length basically means the length of the whole row. This is pretty good, actually. Very good, meaningful names for variables. This exactly is the length of that row of bricks. And that is that the number of bricks. So this n means the number of bricks in that row. And then here is that the length of that row. And then the x, I guess, is the horizontal position of where you should put that current break. So x is get width divided by 2, which is the middle here. And then minus row length divided by 2. So row length is this divided by 2, you got the position here. And then you still need break width minus 2. Why do you still need that?
No. It's like, just add it because it works.
It's minus. Yes.
I did it last night and I was sleep deprived. So I might be alone.
Yeah, so why do you need this? I don't quite
I don't
understand.
know, remove it and see what happens.
So
and then it doesn't work and you're like, huh.
So I equals 0. So which means that this one is number of rows, and this one is in the single row you lay down from left to right, and then so the I is not the sequence number. I instead is the position of that. Because each time you lay a brick, you add a brick width. So I starting from 0, but increment not by a single number. Plus 20, great. Tangle x plus I, y. Why do you need this? And then after you finish with this row, you basically need to go up. And go up means that you actually use this. is actually a pretty neat solution. I need to figure out why do you need this. Because in my mind, this should be enough, right?
Maybe just delete it and see what happens, and then maybe.
Okay. Now I delete it.
Oh no.
And then we try to run it and see what happens. So here I made a breakpoint and then roll that. Oh, I see. You have off by one problem, and that is the correction of that off by one problem.
What? I just kind of forgot it's over. So, yeah.
So let's see. Let's see. We have. What if that's 3? Let's try number 3 here. Give me something.
Zoom it and see what happens.
Yeah, that's what I'm trying to do. So.
It's that one down here. Go down to the. That one down there. It's running. It's just not.
So see,
It's
this is
4.
off by one problem. This is 4.
Oh.
So you have off by one problem.
Also, it looks like it works, but you didn't count the bottom.
So that's why you need this, because you got off by 1. The row length is not the real row length. No, I mean the number of bricks is not the number of bricks. It's not really the total number of bricks. It's the period number of bricks minus 1. So that's why you have off by 1 problem. And so you can see that here is that you're starting from, let's say, 3. And then you want count down to 3, 2, 1. You don't want n to be equal to 0. So you either change it to 1, or there's another way, is to change it to this way. In this way, n can be 3, 2, 1. And then when it's 0, that test will fail, and then you won't have off by 1 problem. And then in this case, let's see what will happen.
Oh my.
There's a problem. So we're
4, 3,
so
2.
this is row length number brick width, and so we still lay down 4, and which means that this loop has a problem. So the row length is 0, and then each time you actually increment it by brick width. So let's say that the brick width, is 30. Okay, 30, and then the first n value is 3. 3 times by 30 is 90. And then I equals 0. The first one, in the first iteration, I will be 0. And in the second iteration, I will be 30. In the third iteration, I will be, so 0, 30, 60, 90. So that's where the fourth one comes from.
So it starts at 0.
It's okay to start at 0, but you should not allow it to reach 90.
So it's row length minus 1 brick width.
So in this case, let's see what this will. Yeah, and then this as actually is not in the middle. It's shifted this way. We'll
No
see.
one can tell.
Yeah, no one can tell in this, but what if
Change it to 52.
23? And then we run
What if you
it.
do a bunch of super small bricks and make it like 100? Oh.
Now you can actually see we're pretty clear this is not in the middle. So
Oh, wow.
well, I have a success today. So I figured out why you need this because you compensate for the offline one.
Oh, so now you can delete that.
Now you can delete that, and then it's in the middle.
Yay.
Now it's in the middle. But still pretty cool actually. You find a neat solution which is a very short program, nested loop with variables naming to be very expressive. And then you make most of the thing right. And you can see that off by one problem is pretty hard sometimes, especially for beginners. And the off by one problems often arise when you made a mistake in the boundary of those loops. Okay, so